Okay, so this is the second video today, July 31st. And so in the previous video, I just introduced all cube. So it worked. However, in reality, we need many cubes in our uh, simulation domain. So I did it. So in this version, I introduce the simulation domain, which is made of 6 by 6 by 12 cube. So this is the net size of our simulation domain, but uh, in this video, I'm not talking about the net simulation domain. This net simulation domain is covered by a container. So, inspired by the game Minecraft, I just name it as Bedrock, and it is like a cup instead of a full box, or empty box. So the upper part is just open, but instead of that, all other five surfaces are covered by bedrock. So in this case, now we have the craft, which is made by three numbers, 6, 6, 12, which defines the size of net simulation domain. Once we specify the size of this simulation domain, then now we can generate a mesh corresponding to this size. And when we go to the mesh, so then inside it, uh, starting from the net size of simulation domain, we add some numbers to have spaces for bedrocks. And yes, here we have bedrocks are made. So this part is corresponding to the lower bottom region, and these are corresponding to the four side surfaces. So now once we make this mesh, then let's come back to our main code. Yes, now we have this guy, then we just show it. When we show it, then show just calls the exporting this mesh information into a CGNS file, and its file name is the same as before, and now it generates a certain CGNS file containing only bedrocks. So let's just do it. So I have prepared a clean version. So let me just make a field and make. Then now we have make a file. Just then yes, as expected, now we have an executable file, AngstromCraft, and just to code it. Yeah, now 6 by 6 by 12 domain is created. Of course, that is empty, only the surrounding bedrocks are found, and as expected, now we have a cube.cgns file. So now let's try to visualize this file. Then now we have this cube. So can you see it clearly? Here we have a x-axis and y-axis, and xy plane is corresponding to the wafer surface plane, and this is the direction is normal to the wafer surface, and now we have this bedrock. So this is just nothing but container. Um, this is not destructive. And when we just show its edges, then now we can see that there are many cubes. And how many cubes along one side? 1, 2, 3, 4, 5, 6, 7, 8. Why we have 8 cubes along a line? Because these 6 are assigned to the real net simulation domain, and this one, left one, and right one are assigned to generate this container. So quite similarly, you can find the same one, and now you can see this will be the position we make our own process emulation. So before finishing this video, let me just make a very quick uh, exercise. Instead of this 6 by 6 by 12, why don't you just go to 60 by 60 by 112, 120, then 60, 60, 120, then just save it and make once again. Then now we have an updated executable, and when we run it, now we have the revised file. So let me just visualize it once again. So what we can expect is still we have a container. However, compared with this container, the simulation domain, the thickness of our container becomes quite thin, because now the entire domain is just 62. Yes, there are 62 boxes along one axis, one direction, and the thickness of each cube in this case is just 1. So now you can see that there are a lot more cubes in it, and now that will be the simulation domain of our process emulation. So anyway, this is just a container, so nothing interesting. So now we must fill this simulation domain with the silicon and other very important materials. So from now on, let's do it step by step manner.